Okay, we're going to wrap up the section 5.4, the fundamental theorem of calculus. This next part is not in your textbook in the same place. It is in a different place. But this is a good spot to introduce these particle motion problems. Again, these do show up quite frequently on the AP exam as a free response question. And a big part of it is just knowing what they're asking for. There are some different keywords that you need to watch out for in this type of problem. So another way to illustrate the net change theorem is to examine the velocity of a particle moving along a straight line, where s of t is its position at time t. Then its velocity, v of t, is the derivative of s of t. And the definite integral from a to b of v of t dt is sb minus s of a. You know, that fundamental theorem of calculus. This definite integral represents the net change in position, or the displacement of the particle. When calculating the total distance traveled by the particle, you must consider the interval where v of t is negative and intervals where v of t is positive. When v of t is negative, the particle is moving to the left. When v of t is positive, the particle is moving to the right. So to calculate the total distance traveled, we integrate the absolute value of velocity, the absolute value of v of t. So the displacement of a particle and the total distance traveled by a particle over an interval is written as total displacement. Displacement on the interval is just the definite integral from a to b of v of t. And you know, some parts of there might be positive or negative. If we dip below the x-axis, that's a negative piece. So here it's a of 1, or a sub 1, minus a sub 2. We subtract that negative part, plus a3, because that is also positive. When we consider the total distance traveled, we want that absolute value of v of t. So we want the definite integral from a to b of the absolute value. We want to make sure we add all these pieces. A sub 1, we take that piece. We add in a sub 2, and we add a sub 3. In displacement, we subtract the negative pieces out. Here we are adding everything together. It's absolute value. So in this example, again, this is not in your textbook, solving a particle motion problem. A particle is moving along a line, so its velocity is v of t is t to the third minus 10t squared plus 29t minus 20 feet per second at time t. What is the displacement of the particle on this time interval from 1 to 5? And all they're asking us here to do when they say the displacement of the particle, they just want the definite integral. So we want the definite integral from 1 to 5 of our function t to the third minus 10t squared plus 29t minus 20 dt. So again, it's just a straightforward definite integral. So we take the antiderivative, t to the fourth over 4 minus 10t to the third over 3, 10 thirds t to the third, plus 29 halves t squared minus 20t on the interval from 1 to 5. And when we run our upper limit through and collect all our terms, we're going to get 25 twelfths minus, we plug the 1, the lower limit, through the same function, and we get 103 twelfths that's negative 103 twelfths. So 25 twelfths minus negative 103 twelfths. We add the opposite, we combine our terms, and we reduce, and we get 32 thirds feet to the right. Feet to the right. And again, we know it's traveling to the right because the answer is positive. If we got a negative value for this definite integral, it would be moving to the left. Positive to the right, negative to the left. And I believe that was, yes. The particle moves, when t is negative, the particle moves left. When it's positive, the particle is moving to the right. So for part A, what's the displacement of the particle across that time interval? 32 thirds feet to the right. For part B, we want total distance traveled. So here's where we want to do the absolute value. The interval from 1 to 5, we want the absolute value of v of t dt. And we're going to have to know when our function is positive or negative. So here's our original function if we factor that. If we get the factors, we're going to get t minus 1 times t minus 4 times t minus 5. So if we set each of those terms to 0, we get x-intercepts of 1, 4, and 5. And those occur at our endpoints and one right in the middle of our interval. If you're on the AP test and this is a free response question, you could factor that with the factoring capabilities of the TID9, or you could graph it and you're going to get this as the graph. So here, we're going to find the sort of area under this curve, and we're going to find the area between this curve and the x-axis and add them together, the absolute value. When we did the definite integral, we found the area under here and we sort of subtracted this out. Now we want the absolute value, so we want sort of all the area between the curve and the x-axis. So we're going to have to break this into two intervals. Our first interval is going to go from 1 to 4, and that's just going to be a straight definite integral from 1 to 4 of our function. So the first piece is from 1 to 4 of our function, t to the third minus 10t squared plus 29t minus 20. And then we need another going from 4 to 5. So, and then the integral from 4 to 5 of our same function. T to the third minus 10t squared plus 29t minus 20. Now when we were breaking one definite integral up into two pieces before, we added them together. Like when we did, let me even just back up to it, the absolute value of a line. Here we add the absolute value of that line, so we did one integral from 0 to a half, and then we added to it this other piece from 1/2 to 2. But do we want to add these pieces? Because remember, what is under here will come out as a negative. If we did that straight up integration from 4 to 5 of our function, because it's here under the x-axis, that will turn out to be negative. So we want to subtract. When we subtract, we'll be subtracting a negative, which will be adding the opposite, and we'll get the absolute value that we're looking for. So what we're going to do here, we're going to take our antiderivative just like we did in part A. So we're going to get t to the 4th over 4 plus 10/3 t to the 3rd plus 29/2 t squared minus 20t from 1 to 4. And then we're going to subtract t to the 4th over 4 plus 10t, or 10/3 t to the 3rd plus 29/2 t squared minus 20t from 4 to 5. So there's going to be a lot of computational work going into here, and what we're going to see when it all boils down, our first set of brackets, we're going to get 45/4 minus, and like we expected, the value in the second set of brackets will be negative, negative 7/12. So we'll add the opposite, get a common denominator, combine our terms, and we're going to get 71/6 feet. Total distance traveled by the particle. 71 divided by 6 feet. Again, to prepare for the AP test, look for these keywords. Displacement, distance traveled. When you see displacement, it's the straight up integration, definite integral. When you see distance traveled, that's going to be the absolute value part. That's where you're going to need a little thinking. Get out the TID9, graph the function or factor it. Find out your x-intercepts. Pay attention to the positive and negative parts of that definite integral.